Okay, the next problem is problem 4. We have the sine of 3x to the 4th. Let's write that as the sine squared of 3x times the sine squared of 3x because we have some power reducing formulas that we can use. And those power reducing formulas are on our formula sheet. So we'll use this formula right here, which is 1 minus cosine of 2u divided by 2. So let me copy that over real quick. Okay, so if we look at this, the sine squared of 3x, we can turn this into 1 minus the cosine of 2 times that u. Now keep in mind, the u is this whole thing right here, 3x. So 2 times 3x is going to give us 6x over 2 times, and we still have 1 minus the cosine of 6x over 2. We have that twice, right? Now I'm going to have to FOIL this all out. So if I do, I get 1 minus 2 cosine of 6x plus the cosine squared of 6x all over 4. All I did was FOIL the numerator and then multiply 2 times 2 to get the denominator. Now the other thing I need to do is take this right here and redo this with the formula, the power reducing formulas. Those formulas are once again on the formula sheet. Cosine squared is 1 plus cosine of 2u over 2. So I'm going to fill this out. This is really 1 plus cosine of 2u now would be 12x over 2. So that's going to get substituted right here, and I'm just going to erase that if you don't mind and put that there. Alright, so I need to simplify this. I'm going to just divide everything through by 4, so I have 1/4 minus 2 divided by 4 simplifies to 1/2. And then I have, this is really 1/12, but then I'm sorry, that's supposed to be a 2 right there. So this is really 1/2, but I'm going to divide it by 4 again right here. So 1/2 divided by 4 is 1/8. Plus, then I have cosine of 12x over 2, but divided by 4 is going to be really cosine of 12x over 8. So now I just need to combine the constant terms. So 1/4 and 1/8. To add those together, I need a common denominator and multiply top and bottom by 2. And that gives me 3/8. So I end up with 3/8 minus 1/2 cosine of 6x plus 1/8 cosine of 12x if I write it in the form that the Webwork wants for this. So up here, I'd put 3/8 here, negative 1/2. This would be 6x right here, or 6. And then I have, it looks like a 12 right here. Okay, the next one is sine to the 4th. So once again, I'm going to make that sine squared of x times sine squared of x, and I'm going to use the power reducing formulas to rewrite this, just like we did in the last problem. Alright, so really I'm going to make this 1 minus cosine of 2x over 2 times 1 minus cosine of 2x over 2. I'm going to put the numerators in parentheses so I don't forget to FOIL. And I'm going to FOIL this out. This turns into 1 minus 2 cosine of 2x plus cosine squared of 2x all over 4. And then once again, I'm going to take this right here and use the power reducing formula for cosine on that to simplify that part. So this would turn into 1 plus cosine of 4x over 2, because keep in mind this is my u that I'm using right here, so I need to multiply it by 2. So now I can simplify that. I'm just going to erase, if you don't mind, 1 plus cosine of 4x all over 2. I'm going to divide 4 into everything, so I have 1/4 minus 1/2 cosine of 2x plus 1/4 divided by 2 is 1/8 plus cosine of 4x divided by 8. And once again, I can add this and this together. And 1/4 plus 1/8, if you multiply top and bottom this one by 2, gives me 3/8. So I have 3/8 minus 1/2 cosine of 2x plus 1/8 cosine of 4x. And that's my answer that they're looking for. And I think they just want A, B, and C here. So A would be 3/8, B would be negative 1/2, and C would be 1/8. Okay, the next problem gives us the tangent is negative 1/3. It tells us the cosine is positive. So it gives us some clues about an angle. Whenever you have that, graph the angle as a reference angle. So the tangent's negative and the cosine's positive. So that means the sine must be negative. So we're looking for a spot where the cosine's positive and the sine's negative. That's in the 4th quadrant. And I can draw a reference triangle there then, where the tangent's opposite over adjacent. So I've got those sides. I can then use the Pythagorean theorem to get the hypotenuse. Hypotenuse would be square root of 10 then. And so now I can find the cosine of 2x, or the sine of 2x. The sine of 2x is on our formula sheet. So I can look at that real quick. Sine of double angle formulas right here. So this is really 2 times the sine of x cosine of x, so that's what I'm looking for. And this is my angle x right here. Actually, my angle x is, this negative angle right here. I'm sorry, it's actually this angle here. But it doesn't matter, I'm going to call that x right there. So I want to do 2 times the sine of x times the cosine of x. So the sine of x gives me opposite over hypotenuse, so it's negative 1 over the square root of 10. And the cosine of x gives me adjacent over hypotenuse, which is 3 over the square root of 10. If I simplify that, that gives me negative 6 over 10, which simplifies to 2 goes into this and makes it negative 3/5. So that's the first one. And we're just going to do the same thing for the cosine of 2x. I can use any one of these formulas if I want. So just pick one. I'll pick, I don't know, the second one looks good. So I want 2 times the cosine of x squared. The cosine of x is adjacent over hypotenuse, so that'd be 3 over the square root of 10. And I'm going to square that, minus 1. All right, that turns into, if I simplify this, 2 times 9 over 10, minus 1, which is 18 over 10, minus 1. I'll get a common denominator by multiplying top and bottom by 10. That gives me 8/10, which simplifies to 4/5. So 4/5 would be my answer for that one. Okay, the last thing I need is tangent, so I'm going to use the tangent of 2u formula. That's just 2 times the tangent of u. They gave us the tangent of u is negative 1/3. And it's 1 minus the tangent of u squared, so negative 1/3 squared. And then I can just simplify that. So this turns into negative 2/3 in the numerator. In the bottom I have 1 minus 1/9, which I'll get a common denominator here. And make this negative 2/3 divided by 8/9. Instead of dividing by 8/9, let's multiply by 9 over 8. So move that up. And then 3 goes into 9 3 times, and 2 goes into 8 4 times, so it's negative 3/4. Right here. Okay, the next problem is the cosine of 22.5. I'm going to make that the cosine of 45 over 2, because I recognize that then I can use this formula, which allows me to use an angle that I know, which is an exact angle of 45. So I'm going to use this. First thing you need to figure out if it's positive or negative. So if we look at the cosine of 22.5, that's over here. And cosine of 22.5 you can tell is positive, because it's the x value. So we know we're using the positive here. So it's the square root of 1 plus cosine of u. Cosine of u now, keep in mind, is u is 45. So it's cosine of 45 all over 2. I'm going to simplify this. It's 1 plus the square root of 2 over 2, because the cosine of 45 really is the square root of 2 over 2. And then I can add these fractions. So this is 2 over 2 instead of 1. So I have 2 plus the square root of 2 all over 2 divided by 2, square rooted. Instead of dividing by 2, I'm going to multiply by 1/2. And so I get then 2 plus the square root of 2 over 4. Now I can simplify that a little bit more, because I can evaluate the square root of the bottom and make that 1/2 times the square root of 2 plus the square root of 2. So that's what they're looking for, because they want up here 1/2 times the square root of, and a would be 2 and b would be 2 as well. Next one wants us to find tangent of 2 times this angle. Now keep in mind, inverse cosine is really just an angle. So what I'm going to do is I'm going to call this theta. I'm going to call inverse cosine of x over 4 equal to theta. Now I can rewrite this as the cosine of theta equals x over 4. And I can then try to figure out what I know about that angle. So what I'm going to do is graph this. I'm going to call it positive, so I'll just put it in the first quadrant. And then I'll label the cosine, which would be adjacent over hypotenuse. And I'll label the other side, which is this side over here, by using the Pythagorean theorem. X squared plus b squared equals 16. Subtract x squared from both sides, so it's the square root of 16 minus x squared. So that's my angle. I'll call that theta once, because that's what I called it. What I'm looking for now is the tangent of 2 theta, right? Because I called that theta. So there's a formula for that in our formula sheet. Let me grab that real quick. The tangent of 2 theta is our double angle formulas right here. Instead of theta, I'm using u here. So I want to do this part right here. I need 2 times the tangent of u. Now the tangent of u is really just theta. That would be the square root of 16 minus x squared over x divided by 1 minus the square root of 16 minus x squared over x squared. So all I did was plug in the tangent of u, which is the square root of 16 minus x squared over x, in for the tangent of u. So now all I need to do is simplify that. So just some algebra, like what this whole section really is about. This turns into 1 minus 16 minus x squared over x squared. If you square both the top and the bottom. And now I'm going to make this x squared over x squared for common denominator, and then subtract. So it turns into this, which would be x squared minus x squared would be 2x squared minus 16 all over x squared. Now I'm going to multiply by the reciprocal, so I'm going to multiply by x squared over 2x squared minus 16. So I just flipped that to the top and flipped it. And then I can simplify. So one of these x's cancels with one of these. And I'm left over with this, which would be, I'll put this x right here, 2x times the square root of 16 minus x squared, all over 2x squared minus 16. Actually, I can factor out a 2 from the bottom and make this x squared minus 8 and cancel the 2 if I want to simplify it a little bit more. And so I'm left with this. And that's pretty good. I don't think I can simplify that anymore. So I'm going to enter that in, use square roots in parentheses appropriately. Make sure you put the top and the bottom in parentheses, and obviously the square root in parentheses as well. All right, I'm going to try this again. Cosine of 67.5. Let's double that. So let's make it 135 over 2 instead of 67.5. That way I can use my half angle identities in the formula sheet. So I'm going to use this formula. Now, my cosine's negative because I'm at 135. So actually, 135 divided by 2, would be positive. 135 divided by 2 is 67.5, which is up here somewhere. So my cosine's positive, so I want the positive value there. And it's 1 plus the cosine of u. Now, u is, in this case, 135 over 2, so that's what I'm simplifying. Now, the cosine of 135 is right here, which we have negative square root of 2 over 2 for that. So if I simplify, this turns into 1 minus the square root of 2 over 2 over 2. So it's similar to the problem we just did where we can make this 2 over 2 and simplify it 2 minus the square root of 2 over 4 if we add these fractions and then divide it by 2 again. Which we could simplify to 1/2 times the square root of 2 minus the square root of 2 if you consider that's more simplified. But they want us to enter it in however we want. So it does say exact value. So if you enter in either one of these, they'll be right. That was probably a little easier to enter in. All right, so they gave us the cosines negative, and they told us that we're between 180 and 270, so I drew a reference triangle and filled out the cosine was adjacent over hypotenuse, did the Pythagorean theorem to get negative square root of 13. And now we're going to use the formula on our formula sheet for the cosine of an angle over 2, which is right here. We know our cosine is negative, so we're going to have negative. So this angle, cosine of alpha over 2 has to be negative as well, because whatever this angle is, if you divide it by 2, you're still over here somewhere where the cosine would be negative. So I'm going to use the negative, and then just fill out this formula. So I just put cosine of u as negative 6 over 7, because they gave that to us, and I just need to simplify this. And here's the work for that. I'm running out of time, but we can enter that in for the exact value. Okay, the next problem gives us theta is pi over 6, which is 30 degrees right here. And they want to know what tangent of twice that angle is, which is really just the tangent of 60. So it's actually probably easier just to do the tangent of 60, which is sine over cosine, without using this formula. But either way will work. You can use this formula if you want, or you can do tangent of 60 off your unit circle, square root of 3 over 2 over 1/2, which you can multiply the reciprocal, and you get square root of 3. Cotangent of 2 times theta would be 2 pi over 12. You can simplify it to 30 degrees and then do cosine over sine for 30 degrees, which gives you this, which simplifies to square root of 3. Next one, secant of pi over 2 is secant of pi over 4 then. If you simplify it, plug in pi over 2 for theta here, and then just rewrite it, 1 over cosine. And I'm out of time, so the last one ends up being negative 2 over square root of 2, and here's the work if you want to pause it and look at that.